Professor Urbis White. Today I will show you how to solve an SSA triangle. I'll explain to you what that means. That is the hardest one to figure out because you are going to get different cases. The other ones, the SAS and SSS, those guys, you can figure them out, but with the SSA, sometimes they call it obscure or, just ambiguous solutions. So you have to kind of pay attention to what you're doing. The math part is easy, but it's kind of like make sure that your trig is straightened away and you are getting the right angles. So let's get started. All right, the ambiguous case, because with this kind of triangle, depending upon the geometry of it, the SSA triangle, you are going to get three possible answers. SSA triangle. So the easiest one is the one that it's not possible, the zero answer. So you either get two solutions, one solution, or no solution. Okay. All right, so let's start with the zero solution one, the impossible case. So I'm going to make up a triangle that has no solution, but nevertheless, it's an SSA triangle. So what that means is, side, angle. Just draw any random triangle. It doesn't matter. So let's say you have a 5 meter and you have a 3 meter. It is out of scale. And then you don't know this one. Side, side, angle. Or you can go this way. So let's go do it this way. Side, side, angle. Side, the side, the side, and the angle. And that one is 88 degrees. Oh, 58. Let's make it 58. All right. Now, this one, the 58 degrees, is going to be big B. This one, you don't know the big C. And A, you don't know. And you don't know the A. All right. So side, side, angle, triangle. So let's put the sine law down. So I'm going to have, so let's say sine of C over 5 is going to be equal to sine of 58 degrees over 3, right? Okay, so let's put this down. So I have crisscross situation. I will put down here 3 times sine of C equals 5 times sine of 58. So sine of C is going to equal 5 times sine of 58 over 3. Get your handy dandy calculator. And let's hide things. So I'm going to do this 5 times sine of 58 divided by 3. And did I get this right? I got a sine bigger than 1. Oh my goodness. So let's go look at the mode. Yeah, my mode was correct. But my sine is too big. It's bigger than 1. That's impossible. So I have an impossible situation. I got a sine. I used the sine law properly, and I got an impossible answer. So that's a zero solution SSA. So understand how that works out, okay? Now, I may get a perfectly good solution, which is that one solution SSA. It all depends how my geometry is. So let's draw a triangle. Random triangle, doesn't matter. Let's say I have a 60 degrees here, and I have a 7, and I have a 5. And is that an SSA triangle? So I know the side, and I know the angle. Yes, it's an SSA triangle. So let's put the letters down. So let's put this as A. So that means this is the angle A. Let's put this as B, angle B. So this is going to be side B then. And did I label everything? A with the A, B with the B. And where is my side C? Here's my side C, and this is my angle C. Alright, so let's write it down. So it's going to be sine A over little a is going to be sine B over little b. Well, let's put in the numbers. Sine A, I don't know. But side A, I do know. Sine B, I do know. And the little b, I do know. Let's crisscross. So I have sine A times 7. That's going to equal 5 times sine 60. So that means sine A is going to be 5 times sine 60 over 7. And let's go get my handy dandy calculator. I have 5 times sine 60 divided by 7. That gives me 0.61859. Now let's take the inverse sine of that. What I'm going to do is I'm going to store this to A. Alright, so that I don't round things. And I will take the inverse sine of that. So that gave me 38.2. Is that the only angle I have? So let's look at it. I got a 38, and the other one should have been 180 minus 38. That is about 150, and it's a pretty big angle. And I already have 60. That's going to be more than 180. So that's the only angle I got. Only possible one. All right. So what do? You can go and you can get the other one. So since I got the A, I can get the B. Then B is going to be, oh, B I already know. So I can get the C. Then C is going to be 180 minus 38.2 minus 60, which is, let's put it over here, 180 minus 38.2 minus 60, and that gives me 81.8, and which also makes sense. Okay, so did I solve for everything? I do have little a, little b. Do I have the little c? I can go and solve for the little c, right? So let's go get that. So if I solve for that, I will get c squared equals a squared plus b squared minus 2ab cosine c. And I did find the cosine c, so let's go solve for that. So c squared is a squared, which is 5, b squared, which is 7, minus 2 times 5 times 7 times cosine of c, which is 81.8. And I'll take the square root of that. Let's move this to the left. So I will have 5 squared plus 7 squared minus 2 times 5 times 7 times cosine of 81.8. And you can store it and you can recall it if you want. And you take the square root of that, and that will give me c of about 8. Let's assume these are in meters. So I did get one solution. I double checked, triple checked, and I got all the sides solved, and I'm done with this problem. What was the last one that we were going to look at? Let's go to a clean page for that one. I will do, let's say, 0 solutions, 1 solution, and I had one that was like 2 solutions. So let's go and do a 2 solution one example. And that's 2 solutions SSA example. That's the ambiguous case. All right? So let's go draw this triangle. Doesn't matter how you draw it, just as long as you say it's out of scale. So let's have 4 meters here, 3 meters here, 3, 4. So I know the side, and I need to know the angle. So here's 28 degrees. I know side angle, SSA. So let's put this as C, little c, and this one is big C. All right, let's put this as B. This one is big B. And let's put this as A, and this one is big A. Well, we are going to start with the sine law. Now let's remember, did we do that for all 3 of them? I did use sine law. So I did, even though this is an ambiguous case, I start with the sine law. So let's write it down. So I will go and I will put down, since I know the side, so I will put sine C over little c is going to equal sine B over little b. So sine C, the big C, I do not know. And little c is going to be 4. Sine B is 28. And little b is 3. So let's crisscross and let's get the sine C solved. Sine C times 3 equals 4 times sine 28. So sine C is going to be 4 times sine 28 over 3. So let's get that. So I have 4 times sine of 28 divided by 3. That gives me a sine C of 0.62596. 0.62596. Let's put this in C, store C. All right, and I'm supposed to take the inverse sine of that. Let's do that. So inverse sine of that is going to be sine inverse of C. And I put it in C here. And that gives me an angle of 38.75. Now here's the trick. Sine is positive. Where is sine positive? Sine is positive up here. Is this the only angle that will give me the sine of 0.625? So let's look at that. If this is 38.75, that's not the only one. Is this a possible angle? That's what I need to look at. 38.75. The other one is going to be 180 minus 38.75. Okay, so how much is that? That's about 141. $247. I don't know if that is possible, because if you look at that 141 and I had 28, that is still under 180. So it is possible. So let's look at that. So if I have that thing, I may have a different situation. So let's look at that situation. So I may have an angle some like this. So I have a 28 degrees here, right? And then I have 38 degrees. So I have 28 degrees, 38 degrees, 38.75, and that one can be perfectly possible. 180 minus 28 minus 38.75. That will give me 180 minus 28 minus 38.75. 113 over 113.25. So that is perfectly possible. So 28, so that, what does that look like? So if I have 113.25, so 28, I have a 3 here, and I have a 4 here, and I can actually go and calculate the A, which is this one. So let's go and write this down. I can write down A over sine of 113.25. That's going to be equal to 3 over sine of 28, right? Because 3 and sine of 28, and A over that thing, 13.25. So does that work? Okay, so let's go and let's get that. So I will get crisscross sine 28 times A equals 3 times sine of 113.25. And that'll give me A of 3 times sine of 113.25 over sine of 28. So how does that look? So 3 times sine of 113.25 divided by sine of 28. That will give me 5.87. Okay, so this is 3, this is 4, and this is 5.87. That is perfectly good, and the angles also work out. All right, but how about the other one? The other one is, what did we get? That one was, let me look. I have to go and get that. 141.2. Okay, that one was 141.2. So if my angle is 141.2, what will be the other angle? That is going to be 180 degrees minus 1.41.2, and that is about, let's see, let's try to draw that thing. Let's draw it like that. So this is 141.25. Okay, and the other one is 28. And how much is that? 180 minus 141.25 minus 28. That gives me about 10.8. That is perfectly good, okay? So, but my triangle is going to look different. So I can put as a over sine of 10.8, and that's going to equal to 3 over sine of 28. And I can calculate the a, which is the angle that, which is the side that's opposite of 10.8. So I get 3 times sine of 10.8 equals sine of 28 times a. So a is going to be 3 sine 10.8 over sine of 28. And that gives me 3 times sine of 10.8 divided by sine of 28. And that gives me 1.197 meters. That's just that, about 1.2 meters. So let's put down the 2 triangles aside, and they're both positive, that all possible. So one triangle will look like this. That's going to be 5.87. That's going to be 28. And that's 38.75. That's 4. And that's 3. That's one possible triangle. The other one, I just put it down. It's going to look like this. And that is going to be 10.8. And this one is 28. And this one is 141.2. And the 10, the one that is the opposite of 10, that's going to be 1.2. And what other sides I got? 1.2, and then you had 3 and 4. Okay, so is that the right sides? No. 3 is this way, 4 is that way. Okay, if you look at it, these 2 triangles are both possible, and I got a 2-solution deal out of this. So make sure that you keep track of it with the SSA ambiguous cases. So you may get 0, 1, or 2 depending upon what configuration your triangle is.